the principle in the hammer mill is impact. So this hammer will impact your material which is coming. See, whatever the material is coming, this material is being impacted by hammer. That's what happens here. So this is the principle of. Today we are going to learn about a topic called size reduction. So what is size reduction? It is also known as, so generally we will see size reduction means when the larger particle size is reduced to small particle, that we call it as size reduction. It is also known as comminution, it is also known as milling, and it is also known as grading. Why this topic is so much important in pharmacy? Because the processes like drug dissolution depends on the size reduction. Absorption is also depends on the particle size. Bioavailability, mixing, flow property, and stability, and even compression of the tablet. So all this process, dissolution means solubility of drug. So dissolution means rate of solubility of drug, we call it as dissolution. Drug absorption, so from when you take the drug into the stomach, from the stomach it has to absorb to systemic circulation, that is called drug absorption. Bioavailability is how much fraction of drug is absorbed into the systemic circulation. So if I give 100% of drug, only 80% or 90% is absorbed into the systemic circulation, that we call it as bioavailability, fraction of drug absorbed. Next is mixing efficiency. So if you are mixing anything, if particle size are not even, so all larger particle will be at the top of the powder, and smaller particles will be at the bottom of the powder. So there will be no proper mixing. So to get uniform mixing, you should have uniform size of particles. Then flow properties. So when the powder is flowing from the hopper to the tablet machine, okay. So when it is flowing from the hopper to the tablet machine, the powder, if the particle size are not even, then what happens? Larger particles will flow first, which leads to larger dose in the few tablets which are manufacturing. Smaller particles will flow last, which leads to smaller dose in the later tablets. So the tablets which are coming first will have larger dose, and the tablets which are coming late will have smaller dose. Next is stability. Okay, and also even for tablet compression. So these are the reasons why we are studying this chapter in the pharmacy. What is the objective of size reduction? So first one is to increase surface area. If you reduce the size of the particle, see, we have a larger particle here. When you reduce the size of the particle from larger particle to smaller particles, so compared to the surface area of this larger particle, the surface area of the all small particles together will be more compared to one particle. So all small particles surface area will be more. So this increase in surface area will affect your dissolution, chemical reaction. More surface area, more dissolution, more surface area, more chemical reaction. If you are going to extract anything from the product, let's say we have plant bark, I want to extract something from the plant bark. If I put the whole bark like that and try to extract, the extraction process will be very less efficiency. When I reduce the size of the same bark, okay, see like this, if we have a bark, plant bark, if I reduce the size of this plant bark into smaller blocks, so the smaller blocks have more surface area. Due to this, extraction will also be very good. Next, drying and mixing. So if you dry a larger particle, it will take more time compared to same particles which is been dried in the smaller particles, and also mixing will be uniform. Then see, example is, what is the example for increasing surface area is, finely powdered paracetamol dissolves faster than coarse paracetamol granules. So the paracetamol granules which are very small, these small granules will dissolve faster compared to the large granules. Okay, that's what it is. Next, improve bioavailability. If the drug is belonging to class 2, so you need to understand is what is BCS classification. We classify the drugs depending upon their permeability and solubility into 4 classes. So class 1 drugs are those drugs which are having more soluble, more permeable, like this. So class 1 will have more solubility is more and permeability is more. Class 2 drugs are those drugs which has less solubility and more permeability. Class 3 drugs opposite to this, more solubility and less permeability. Class 3. Class 4 drugs less soluble and less permeable. Okay, in this check about class 2 and class 4, we have less solubility. So for this type of drugs, the size reduction will help to increase the bioavailability. So the classification BCS means biopharmaceutical classification system. So class 2 drugs are poorly soluble. When the particle size is reduced, their solubility will increase, dissolution will increase, and also their bioavailability, the amount of or fraction of drug which is absorbing in the systemic circulation, will also increase. Example, griseofulvin when micronized shows better absorption than non-micronized. Micronized means reducing the particle size to micron is called micronization process. So griseofulvin when micronized shows more solubility or better absorption compared to those griseofulvin which is having less solubility. Next, homogeneous mixing. I told you, if particle size is uniform like this, if particle size is uniform, mixing will be uniform. If you have particles larger like this and you have particles smaller like this, there will be no uniform mixing. If the particles are in this type, then only there will be uniform mixing. If the particles are like this, there will be no uniform mixing. That's what the problem is. So even distribution of drug and excipient. So I have drug particle, I have excipient particle, drug, excipient. So even mixing will happen. Otherwise, we have all drug particles at one place and all excipient particles are other place, which is not a even mixing. So even mixing of drug and excipients. Next, accurate dose uniformity. I told you, if the particle size is same, when they are flowing from the hopper to the punching machine. So from here they are flowing like this. If the particle size is large particles will come first. So initial 10 tablets will have more dose and later small particles will come. Then final 10 tablets will have less dose. So dose uniformity will be not there. In the same tablet strip, in the 10 tablets, 5 tablets will be having more dose, 5 tablets will be having less dose. Do you accept this kind of tablets? No. So if I am keeping the dose of 500 mg in each tablet, the dose should be same in all the tablets. So to get uniform dose, okay, to get accurate dose uniformity, we need to size reduce the particle. Next, prevention of segregation. Okay. So to prevention of segregate, we need to have uniform size particles. If the particle size are not uniform, they will try to segregate. See, larger particles try to segregate from the tablet compared to, and also smaller particles try to segregate. If the particle size is like this, if the particle size is uniform, so you can prevent the segregation. I told you, when mixing all large particles, see here, let's say I have particles like this, large, small, large, small, large, small, like this. If I mix them, what happens? All large particles will be segregated at the top and all small particles will be segregated at the bottom like this. This type of segregation we should not have when we are mixing. So to prevent this segregation, we need to size reduce the particle to uniform size. Not only size reduction, the particle size should be uniform. All the particles should have same size. Next, improve the flow properties. I told you, from the hoppers, from the feeders in the tablet compression machine, when the particles are flowing, to improve the flow property, if the particles are not larger in size, there is a chance that they will attach to each other and they will not flow. If the particles are very small, the flow property is more compared to the larger particles. Okay, which prevents weight variation in the tablet. So all tablets will have same weight. If you are not using uniform size particles, initial tablets will have more weight and more dose, and the final tablets will have less weight and less dose. So weight variation will be not there if you are not going to size reduce the particle. Next, facilitate formulation processing. So in granulation, we want small size. Sifting means segregating the particles. Blending means mixing. Tablet compression and capsule filling. We need to have optimum size of the particle in this all process. Next, increase stability. Reducing particle size helps stabilize suspensions by slowing down the sedimentation rate. See, we have a suspension. Let's say we have particles we are suspended in the liquid. If the particle size is very small, these small particles will be always in the Brownian movement. Due to that Brownian movement, the effect of gravity will be nullified. So gravity will not affect the small particles which are in the Brownian movement. If the particle size is large, there is a chance of settling in the suspension. So you don't want the suspension to settle. If the suspension is settled, it means not stable. If the suspension, the particle in the suspension, if the particles are always suspended, then only we call it as stable suspension. If the particles are settling in the suspension, then we call it as unstable suspension to increase stability. So according to Stokes' law, if the particle size is reduced, gravity influence will be less and the rate of settling will also be less. That's what it is. So increase the stability. Stability means in the sense of suspension. Next, improve extraction efficacy. I just told you. So if you are taking one bark, I want to extract something from this large bark. Instead, if I make this large bark into small pieces like this, due to this what happens? The area, surface area will increase. So from each bark there will be particle, there will be extraction. Compared to one full extraction process of a unit bark. So if you make that bark into small particles, from each particle there will be more extraction. So the extraction efficiency will be more. So it is used in herbal industry, decoction preparation and percolation and maceration, these are the things which you are going to study in pharmacognosy. Next, if you are drying, if you are drying a granule, if the granule is this much big, compared to this, if I make this granule small like this, so surface area more air will come in contact with these granules and there will be more drying. That what happens. Compared to the larger particle, compared to the larger particle where the drying efficiency is less, the smaller particles will have more drying efficacy. Next, what is the mechanisms through which size reduction happens? So there are different equipments we are going to use. So for different equipments, different mechanism will be there. So we'll try to study all mechanism at once. First mechanism is compression. Compression means compressing like this. If you are putting a heavy thing on the small thing, that heavy metal will compress the small one. Due to this compression, the size reduction occurs. So example is your roller mill, edge runner mill, are useful. These are useful for hard and crystalline materials. If the material is hard and crystalline, then you need to use compression mechanism. Fibrous drugs. So drugs which are fibrous also, we need compression mechanism. So compression means the heavy thing is sitting on the smaller thing. This heavy thing will compress and size reduce the particle. Next, impact means, see, this is impact. So one particle is impacting other particle, or particle is going and impact to the wall like this, or particle is impacting to the hammer like this. So this is the hammer impacting the particle. This is called impact. So sudden and high energy force are applied in the impact. So impact, sudden and high energy force is applied in the impaction. So where we see this? In the hammer mill, fluid energy mill and ball mill. See, hammer will impact. Fluid energy mill, two particles will collide with each other. Particle-particle interaction. In ball mill, balls will be falling on each other. In between the balls, if the particle is there, this particle will be crushed. That's what it is in the ball mill. So it is suitable for brittle materials and also intermediate hard materials. If a material is hard, then go for compression. If the material is intermediately hard, then go for impaction. Next we have attrition. Attrition means this one, like this. So they are sliding on each other. So while they are sliding on each other, the particle size will be reduced. This is called attrition. So attrition, particle rub against each other. So they rub against each other, or they rub against each other, or they rub against the surface by generating the force. Okay, due to the generation of the force. Example, again in ball mill, the particles will attach with the balls, and also in colloidal mill, particles will attach with each other, colloidal mill. Okay, next. Or in colloidal mill, the particle will be attached between the two plates. So two plates will be rotating like this. In the colloidal mill, the particle will be attached between the two plates like this. Next is cutting. Cutting, we can cut the particles. So knives or blade are involved. So cutter mill or knife mill. So fibrous materials and tough materials are used in cutting. Combination mechanism. So you can combine. So if you take hammer mill, we have impact and attrition. Ball mill also impact and attrition. Edge runner mill, compression and attrition. Both. Okay. These are the things these are the mechanisms in which the particle size is been reduced. Okay. Now we'll see what are the factors affecting size reduction. So what are the factors affecting size reduction is obviously hardness. The material is hard, it requires more energy and it will damage the equipment also. Soft material are easy to grind. Hard materials measured by the hardness of the material is measured by Mohs scale. Okay. So example is talc is a soft material, diamond is a hard material. Toughness. Material like rubber are tough and resist size reduction. You take rubber and try to size reduce it is not possible. So cryogenic grinding can be used. What is cryogenic grinding? Is take rubber, put that rubber in a liquid nitrogen. If you put that rubber in a liquid nitrogen, that liquid nitrogen will convert that rubber into solid, crystal solid. If you hit the rubber after it is been cryogenized, or you can say freeze. Okay, if you hit that rubber will break. Best example is take rose flower. Dip that rose flower in the liquid nitrogen. So that liquid nitrogen will break that rose flower. Next is moisture content. So high moisture cause clogging and sticking. Low moisture cause increase in brittleness and makes grind easier. Low moisture. So the optimum moisture should be less than 5%. If you are going for size reduction of any particles, the optimum moisture should be less than 5%. Next, stickiness. So gum-like or resinous materials cause aggregation, clogging and poor grinding efficiency. What is the solution for this? Cool the mill. If you cool it, the gummy property will be reduced. Freeze the mill. If you freeze, again the gummy property will be reduced. Or you add, because materials are sticking to each other, it is better to add anti-sticking agent. Next, feed size. Larger feed particle require more energy and reduce efficiency. So use in small batches. If you have this much big batch, use in small batches so that your grinding efficiency will be more. Next, temperature. Heat produced during mill. Okay. Low melting drugs. If your process is producing heat, low melting drugs like phenacetin will melt, cause degradation for vitamins and antibiotics. In such case, you need to select those process where there is no production of heat. Best example is fluid mill. In fluid mill, there will be no heat produced. So this can be used to reduce the size reduction of thermoliable or melting drugs. Next, material structure. Obviously, crystalline material will break easily compared to amorphous material. Amorphous material, when applied force, will deform and resist the fracture. Crystalline material, fracturing will be easy in the crystalline material compared to amorphous material. Next is your mill type and speed. Okay, what are the types of mills you are using? So that is also very important. Mill types and also speed. Okay, so high speed, high impact forces, fine particles will be generated. So high energy mill or fluid energy mill will be considered for to get small particles. So next we'll see principal construction working and merits and demerits of each mill. So first we'll see about hammer mill. Hammer mill, the principal is impact. So a hammer will impact the material like this. Hammer will impact the material. Hammer swings at high speeds and it will strike the particle. This hammer will swing at high speed and it will strike the particle like this. So I'll try to show you the video for this. Yes, check the working of hammer mill. So what happens here is we have hammers here. Okay, these hammers are swinging at high speed. See, material is coming from up. From here the material is coming. So from here the material is coming. This material is being rubbed by the hammers. So that is what happening in the hammer mill. Okay, hammer mill works. So the hammer mill, hammer mill, the principle in the hammer mill is impact. So this hammer will impact your material which is coming. See, whatever the material is coming, this material is being impacted by hammer. That's what happens here. So this is the principle of hammer mill. So this is the principle of hammer. That's what you saw in that hammer mill. Okay. Now, size reduction in the hammer mill is due to impaction. Construction, we have feed hopper from where the material is coming. We have rotating shaft where the shaft is rotating. We have hammers where the hammers are rotating. Metal casing will be there around this, and perforated screen will be kept at the bottom. At the bottom we have perforated screen. Whatever the particles which are been size reduced, the particles will be coming out from the perforated. And we have discharge outlet. What is the working? Material enters to the hopper. Hammer rotates at high speed. Particles are struck and broken by the impaction. Small particles passes through the skin. Oversized particles will stay above the screen. Small particles will come below the skin. Whatever the oversized particle which will stay above the screen will be again hammered by the hammer mill. What is the uses? Uses are crude drug grinding, spices grinding, resins and bark, intermediate milling for tablets. Intermediate milling for the tablet. Advantages: high efficiency will be there. High efficiency means almost if you put 100% of product, 99% of product will be size reduced. That what is high efficiency. So handles hard materials. It can handle the hard material, simple operation, and adjustable particle size. You can adjust the particle size. Only thing how to adjust the particle size is if you increase the length of the hammer, the particle size will be very small. If you decrease the length of the hammer, the particles will be very large. See here, large particle will be there. If you increase the length of the hammer and the shaft, the particle size will be small. So you can adjust the particle size. What is the disadvantage is heat generation. You can't use thermoliable drugs. Thermoliable drugs are those drugs which are degraded by the temperature. So you can't use the thermoliable drugs here. More dust production, not suitable for sticky material. The material will stick to the hammer and it will be continuously rotating. So it is not suitable for sticky material. Obviously, because hammers are there, wear and tear will be more. Next we'll see about ball mill. First we'll see the video about ball mill. See here, this is how the ball mill looks. So balls are moving. See, balls are impacting with each other and also with the wall, and also they are attrition. They are rolling on each other. They are rolling and also they are impacting. So this is what the mechanism of ball mill is. This is how the ball mill will work. So the principle is impaction and attrition. So balls, you just saw now, balls are falling on each other, that is impaction, and balls are rubbing on each other, that is attrition. So construction is obviously cylinder will be there. You saw that cylinder. In that rotating shaft will be there. Grinding media will be there. That is your balls. Okay, which are made up of porcelain or steel, mainly stainless steel, because stainless steel is unreactive to the all substance. So you need to, in the constructions of material of any of this mill, you need to note that the material which is being used for construction should not react with the material which is being used. Okay, working, we have a critical speed. Where bar rise and fall on each other, particles are trapped between the balls, attrition occurs, continuous batch operation. So you can get up to a size of 10 to 50 micrometer. What are the uses? Fine grinding of drugs. If you want to finely grind the drugs, if the drug is stable, heat stable drug, then you can go to this one. Okay, next, pigments. It is used for pigments. Ceramic materials can also be used, and preparation of nanoparticles. You can prepare nanoparticles by using modern design ball mills. Advantage is produce fine and uniform particles, suitable for both wet and dry grinding. So wet grinding can also be possible and dry grinding can also be possible. It means if the powder has more moisture, okay, no problem, we can go there. Not excessive moisture, but comparatively we saw the powder should have less than 5% moisture. If your powder is having 10% moisture, 15% moisture also, you can go for ball milling. It can be used for heat sensitive drug. So this can be used for heat sensitive drug because more heat is not produced here. Batch or continuous operation can be done in this. Disadvantage is the process is very slow. It will take so much time. High energy consumption, wear and tear of balls, not suitable for, the material is sticky, the ball will stick to each other. They will not cause your attrition and impaction. Next we'll see the fluid energy mill or jet mill. We'll try to see this. See, you can clearly see. So in this mill, so we are feeding we are feeding a solid here. From this we are feeding a solid. From the bottom we are giving the compressed air. The air which is compressed is given from the bottom. So the solid is fed here. From the bottom we are giving the compressed air. So see that solid material, see now it comes down. Air is very compressed. So they are impacting each other. So the here impact and attrition will happen both. See here. So the particles will come like this. The air will be flown. This zone we call it as vortex zone. Here the vortex is formed. Okay, the particle will rotate for some time here in this zone. This whatever the zone is there here, we call it as vortex zone, where the particle will be entrapped. This how the working of fluid energy mill will be there. So here we'll blow the air. Air will make the particles to rotate and collide with each other. That's all. That is the simple logic behind the fluid energy mill. Okay, so the principle is high velocity collision, impact and attrition. I just said you. High velocity collision. Air will be flowing very fast and the particles will be collide with each other and also attrition with each other. Here the collide and impact and attrition happens between the particles. Construction, we have grinding chamber. I showed you that oval circular chamber. Okay, then we have nozzles, feed inlet and classifier outlet. So compressed air up to 1000 m per second is used. So this is a compression unit. So working, high pressure air enters tangentially. We just saw from here the high pressure air is entering. Okay, material is fed into the chamber. So then particles accelerate and collide with each other. Fine particles ride. The fine particles will rise. They will come out through the exit. I will show you once again. See here. So what is happening here? Compressed air is sent from this side. From this side the compressed air is sent. Here the feed is been there. Once the particles, after particle get collided, here in this chamber the size reduction will happen. Once the particles rise to each other, when they come to this one, see here, this here, all small particles will come out. Okay, you can remove the small particles from there. So continuously this operation will be going on. That's what it is. Okay, so what are the uses? Because heat is not produced, heat sensitive drugs can also be used. Antibiotics, steroids, vitamins and inhalation powders. Remember, antibiotics, steroids, vitamins and inhalation powders are being used for heat sensitive. These are the heat sensitive drugs. So this can be used for size reduction in the fluid energy mill. So no moving parts, obviously there is no contamination. Very fine particle size will be achieved. No heat generation, suitable for thermoliable there. What are the disadvantages? High cost. The cost is very high. Okay, required skill and maintenance, slow out throughput, slow process, not suitable for sticky material. Material will stick to the wall, they will not rotate in the fluid energy mill. So we have edge runner and end runner. Edge runner means runner will be there at the edge. First I will try teach you this, then we'll try to see the diagram. So edge runner, compression and attrition. It will compress and it will also attrit. Best thing is our idli batter or dosa batter is produced by edge runner and end runner. So edge runner we have so our idli batter or dosa batter is been prepared by edge runner. Two heavy granite or metal wheels will be there. This wheel will be rotating. Under this the particle will compress and also it will be attrition to get the particle size reduced. So shaft will be there, bed or pan will be there. Working. What is the working? Material is placed in the plant. Heavy wheels rotate and crush the material. Grinding occurs by compression of the wheels, shear of the wheels of slide. Okay, then material is mixed and grounded simultaneously. Material is mixed and grounded simultaneously. How it is, we will try to see. Edge runner. I will show you. See here. See here, edge runner mill, what is happening? Two wheels are there which are rotating against each other and they are compressing and attrition. Both things is happening here. Compression and attrition is going to happen here. That what is your edge runner. So your idli or dosa batter is produced by the edge runner. That what is your edge runner. They are running at the edge. Hence the name is given edge runner. Uses mixing and grinding of ointments, crude drugs, crushing of crude drugs and wet mass in tablet granulation. Advantages: good for mixing and grinding, handles fibrous materials, low heat generation. The heat generation is very low. But the disadvantage is very slow process, labor intensive. Okay, large space for the equipment and not suitable for fine powders. The powder should be coarse, then only it will. If the powder is already fine, you can't go for edge runner. End runner means at the end there will be runner. Here at the edge we have a runner, at the end there will be runner. So construction we have one wheel, end runner have one wheel, edge runner has two wheels, remember. So end runner has heavy one wheel, motor pan, scraper and material is placed. How it works? That wheel will rotate against the wall. Okay, material is crushed between the wheel and the base. Okay, then mixing and grinding occurs simultaneously. Okay, both occur simultaneously. Compression and shear. Here the principle is compression and shear. We will try to see end runner now. See here, this is end runner mill. See, at the end we have that roll. One roll will be there at the end. So scraper will be there which will scrape. Here it will compress and shear, both. Shearing and compression is happening at the end runner. Due to this, the particle size will be reduced. This is the best example for end runner. At the end there will be runner. Previously we saw edge runner. At the both edges we have runner. So this runner is there at the end. Hence it is called as end runner. Okay. Uses fine paste, semi-solid mass, pulverizing gums and resins. That can be done by the end runner. Advantage is good for moisty and pasty material. If the material pasty is also no problem. End runner will be at the end of the machine. We saw that. So here the paste material will be crushed like this. So it will be rotating. The paste material will be crushed. Simple construction, low heat production. Disadvantage: not suitable for dry fine powders. It is not suitable for dry fine powders. If the powder is wet, go for end runner. Slow output and requires manual supervision. I hope you understand. Thank you.